Good evening, student. In the previous lecture we discussed about the process of fixation. What is by fixation? Fixation means preservation of all or as many as possible cellular and structural elements in their original state. So there are two types of fixative, that is primary fixative and compound fixative. Primary fixative is also called as common fixative, which is used for general laboratory purpose. The classical examples of primary fixatives are ethyl alcohol and formalin. The second one is called as compound fixative. Compound fixative is also called as fixative mixture or microanatomical fixative. The term fixative mixture is used when two or more substances are mixed together to fulfill our ideal requirement. This fixative mixture is also called as microanatomical fixative because they fixes each and every organelle, cell organelle. So there are three types of compound fixative, that is Bowen's fluid, second one Cornay's fluid, and the third one is called as Zinker's fluid. Let us focus on Bowen's fluid. Is it visible, student? Okay. So here the first example is Bowen's fluid. Bowen's fluid. The classic, this Bowen's fluid is mixed by three chemicals, that is saturated solution of picric acid 75 ml, then add 40% formaldehyde, 40% formaldehyde is 20 ml, and in which add glacial acetic acid 5 ml. So this solution is called as Bowen's fluid. Is it right? The advantages of Bowen's fluid is this Bowen's fluid is made as a stable stock solution. So here advantages of Bowen's fluid. It can be made as a stable stock solution. And is ready for use at any time. The second advantage is the fixation time is recommended for 12 hours to several days. 12 hours to several days. But the best staining results are achieved if the material is processed as soon as after fixation. That is, if the fixation time is over, then immediately you should transfer to the next grade. Then fourth advantage is Bowen's fluid is excellent fixative for both whole mount and tissue preparation. The fifth advantage of Bowen's fluid is this fixative is excellent for marine invertebrates. And for most mammalian tissue. Okay. Then by using this fixative, it produces very little microanatomical disturbances. Means there are very little changes occurs in the tissue after fixation. The seventh disadvantage is Bowen's fluid permits brilliant staining result. Results. That is, excellent staining results are achieved by using this Bowen's fluid. And last one, this Bowen's fluid, it permits yellow color to tissue. Which is useful for handling the tissue. Right? So these are the advantages of Bowen's fluid. Right? It is visible? Yes, yellow color to the tissue. Though it have these advantages, but on contrary, it has some few disadvantages. Let us focus on disadvantages of Bowen's fluid. So disadvantages. Okay, disadvantages of Bowen's fluid. Right? So this Bowen's fluid penetrates poorly. So its usefulness is restricted to small piece of tissue only. It is not recommended for large size tissue. Okay? Because penetration power. The second disadvantage is the picric acid which is used in Bowen's fluid. This picric acid, it forms water soluble compounds with many organelles of the cell. So large vacuoles are seen in the tissue. So this is because of picric acid. And the third disadvantage is that the picric acid or this Bowen's fluid is very difficult to wash. Okay? So these are the disadvantages. Now we will focus on properties of Bowen's fluid. Properties of Bowen's fluid. Okay, friends. So here formaldehyde. This formaldehyde fixes cytoplasm as well as nucleoplasm very well. That is, formaldehyde has ability to fix both cytoplasm and nucleoplasm. But this formaldehyde, it hardens the tissue. Due to this, what happens? It cannot penetrate the paraffin for entering easily. It prevents the entry of paraffin. But the picric acid which is used in formaldehyde, what it did, this picric acid, it makes the tissue soft in such a way that they readily admits the paraffin. So what happens, this formaldehyde, it harden the tissue, while picric acid, it soften the tissue, so that paraffin get readily admitted into the tissue. The third property is it visible? Here, this Boyne's fluid, in this Boyne's fluid, formaldehyde fixes, what it did, formaldehyde fixes chromosomes poorly. That is, it has not ability to fix the chromosome properly. But the picric acid, it fixes chromosome very well. Okay. The fourth important property is picric acid is much more soluble, or picric acid is responsible for shrinkage of tissue. Picric acid, it is responsible for shrinkage of tissue and makes the chromatin acidophile, This results in formation of vacuoles in the tissue. So these defects are compensated by using, is it visual? These defects are compensated by using glacial acetic acid. Is it? That's why we are using formaldehyde, picric acid and glacial acetic acid as a mixture, and these collectively called as Boyne's fluid. Right? Now, here we also used alcoholic Boyne's fluid. Alcoholic Boyne's fluid. How it can be prepared? So for that purpose, take 1 gram of picric acid, 1 gram, then 40% formaldehyde, 60 ml, then take glacial acetic acid. The amount of glacial acetic acid is just 5 ml. This mixture is dissolved in 70 to 80% alcohol, and this alcohol is taken in the quantity of 150 ml. Right? So this mixture is called as alcoholic Boyne's fluid. Okay. The primary use of alcohol is to increase the concentration of picric acid in the solution, because the picric acid is much more soluble in alcohol than in water. So to increase the concentration of picric acid, we are using alcoholic Boyne's. This alcoholic Boyne's fluid is recommended for very dense object. It also recommended for fixation of decalcification of bone marrow. Right? So this is about the alcoholic Boyne's. Now the second type of fixative is called as, we just heard about, that is Cornuy's fluid. Here it is visible? Yes. Cornuy's How it can be prepared? There are two formula, that is formula 1, formula first and formula second. Here in both formula we have to take absolute alcohol. Absolute alcohol. This absolute alcohol is taken in quantity of 60 ml. 60 ml, both formula first and second, 60 ml. Then glacial acetic acid. Glacial acetic acid. Just 20 ml in formula first and 10 ml in formula second. And the third component is, that is chloroform. Chloroform. In formula first, chloroform is not used. In formula second, take 30 ml chloroform. So this is the difference between formula first and formula second. The formula first is more general used. This formula first is more general used than formula second. Although the chloroform increases the rate of penetration, the period for fixation is recommended for 10 minutes to 3 hours. And the fixed tissue are directly transferred to the alcohol. That is, it is not necessary to wash the tissue in water. The tissue are directly transferred to the 70 or 80% alcohol. So this is the advantage of Cornell's fluid. So let us focus on advantages of Cornell's fluid. Here. Is it visible? Yes. Advantages of Cornell's fluid. Okay, friends. So the first advantage. This Cornell's fluid is used for dense object. That is arthropod eggs, ascaris eggs, nematode eggs, and all delicate eggs. For fixation of this dense object, we used Cornell's fluid. The second advantage is the fixation is very rapid. Fixation is very rapid because just before I told that the time of fixation is 10 minutes to 3 hours. As compared to Bowen's fluid, the fixation is rapid. The third advantage is this fixative, it permits good nuclear staining. Good nuclear staining. The fourth advantage is glycogen is preserved. That is, if the Cornell's fluid is used in that tissue, glycogen is preserved very well. And after fixation, the tissue are directly transferred to alcohol. Right? So these are the advantages. Though it has advantages, but it has few disadvantages. Disadvantages of Cornell's fluid. So which are the disadvantages? The first disadvantage is that this fixative, it causes excessive shrinkage. Excessive shrinkage is caused by this fixative. The second disadvantage is that it is suitable for only small pieces of tissue. Right? And the third one is that in this fluid, RBCs are broken down. They get burst. So these are the disadvantages of Cornell's fluid. Now, here The third fixative is called as Zinker's fluid. Is it visible? Good. Third one is Zinker's fluid. The formula of Zinker's fluid is take potassium dichromate, that is K2Cr2O7, potassium dichromate 2.5 gram potassium dichromate. Then mercury chloride AgCl2, mercury chloride 5 gram, right? Then take sodium sulfate 1 gram. So these three solid materials are mixed in distilled water 100 ml, and this mixture is called as Zinker stock. This is called as Zinker stock, right? Then take 100 ml Zinker stock 100 ml, in which add 5 ml glacial acetic acid just before use. 5 ml glacial. This solution is called as Zinker's fluid, right? This Zinker's fluid has advantages. The first advantage is, the first advantage of Zinker's fluid is the tissue is fixed in this fixative, gives excellent nuclear staining result. Excellent. Staining results are achieved by using this fixative. It is also best for connective tissue. Best for fixation of connective tissue. And the third advantage is it is recommended for general purpose also. General purpose also, right? Yes. Then this Zinker's fluid has few disadvantages. Let us focus on disadvantages of this fluid. Disadvantages. The first disadvantage is penetration power is very poor. Penetration is very poor. Second disadvantage, the piece of tissue should not more than 5 centimeter in thickness or diameter, right? That is, it is recommended for only small piece of tissue. The tissue in Zinker's fluid should be kept for minimum time. If the tissue can be kept for more time, then it will brittle the tissue. It will become brittleness. Then fourth disadvantage is that the tissue must be washed in running tap water. Running water for several hours to remove fixative. That is, it is difficult to wash. And the fifth disadvantage is that it forms, or tissue forms, PPT of picric acid, chromic acid, and mercuric acid into the tissue. That's why we are not using this fixative. So we are recommending that Bowen's fluid is excellent fixative in our laboratory. So we are using this Bowen's fluid for fixation. Okay friends, now we will stop here.